Today I would like to talk about what it means to be a host, but also a little bit, say, from the framework of the fellow, the potential fellow, to apply for a postdoctoral fellowship, but including a non-academic placement. So as already was introduced, my work mainly focuses on colloidal semiconductor nanocrystals, but also called quantum dots. And for the reason that the big ones, as you can see here on the left, they are big and emit red light, for instance, but as the size of these quantum dots grows smaller, you have something what we call quantum confinement, and the color actually changes to blue. You can also see this in this image here, for instance, where as the size goes down, this color of these nanoparticles changes. Okay, sorry, I lost the screen here a bit. Why is that? Just a sec, I'll reshare. Okay. So that also brings me to a very first important point. You need to, as a fellow, find a suitable host, which means that you need to look at your personal skills and the say skills that you aim to acquire, and see if there's a good match between yours and the ones of the supervisor. Yeah. And then, as I mentioned already before, this fellowship also concerns a non-academic placement. And the reason why I personally think that this is important is that if you look at this research pyramid at Ghent University, for instance, you see that if you look at the numbers, there's, say, about 6,000 PhD students, 1,800 postdoctoral researchers, and about 1,500 professors. Now, this looks quite, say, favorable still, but then you have to consider that a typical professor has quite a long career compared to a postdoctoral researcher. So if you look at turnover rates and the number of people that need to be hired per year, you see that for 50 professors, there's 240 postdoctoral researchers and about 1,500 PhD students. So the ratios are essentially saying that only 1 in 6 PhD students will be eventually become postdoctoral researchers, and only 1 in 5 postdocs eventually makes his way to permanent academic staff. So those numbers are meaning also that 4 out of 5 of those postdocs, despite their excellence, despite, say, all the skills that they have, they might need to diversify a little bit. And that's why I think that research and development positions in industry can be a very, very attractive career path. Yeah. And then if you look at the MSCA scheme, I think this concept of the non-academic placement is a perfect moment where you in your career can test whether you're a suitable match to an industrial environment. Yeah. So if you look at, say, the research field that I work in, these colloidal quantum dots or nanocrystals, I show you here the number of publications that were published, say, over the past few decades. And a few things are emerging here. You see that there's a very interesting new rise in perovskite nanocrystals, for instance. The group of cadmium-based nanocrystals is declining a little bit, and there's a small but steady group of people working on 3,5 nanocrystals, say indium phosphide, indium arsenide-based nanocrystals. In terms of applications, you see there's a lot of work recently being done on LEDs and displays, a little bit less on lasers, and also there's some work on solar cells and photodetectors. Now, why do I show you this? It shows you that, say, from an industrial point of view, there's actually quite a lot of interest in LEDs here based on RoHS compliance, on non-toxic, non-heavy metal or heavy metal free nanocrystal materials. And the typical application is, for instance, the display, the quantum dot TV, from which I showed you this picture here from Samsung. So try to find a little bit, say, what is the non-academic interest in the research field that you're aiming for? In our case, say the industry is mostly interested in working on displays using non-toxic nanocrystals. And we were, say, very lucky. So talk to your host, see what kind of suitable industrial placement can be found. And in our case, actually, next to Ghent University, we have a number of spin-offs. And one of those spin-offs is actually working on colloidal quantum dots. So it actually spun out of our own research group here at Ghent University, and they are called Custom Dot. So Custom Dot are in fact making these non-toxic indium-based indium phosphide nanocrystals for displays. So we decided to talk to them. So we took, say, the interests and the skills of the fellow together with my interests. We start talking with the, say, industrial potential collaborator, and decided what we wanted to do, what we could do together. Yeah. The reason why I say this talking is important is that you want to, of course, in the end, have one coherent research proposal. Yeah. You don't want to have a complete disconnection between the non-academic placement and the research that you execute at your host. So what we decided in the end for our fellow was that we're going to work on these ROS-compliant 2D nanocrystals to make a display pixel. So the 2D nanocrystals are perfectly in line with what I do in my research group. You see that we decided to work on zinc selenide-based nanoplatelets. Why is that? Because they actually have very good emission in the violet up to green range. And this could be interesting for Custom Dot because now they work on indium phosphide, but it might be able for them to diversify their portfolio into other emitters. And you see, they have a very strong expertise in red and green materials. They could actually expand their technological developments into, say, the blue up to the violet, maybe even UV. So you see, after these discussions, we came to an agreement, something to work on, which is of interest for all the partners. Yeah. So that also means that at this stage, it's good to be open. It's good to share your ideas with that industrial partner so that they become interested in what you could offer, and that they're interested in this non-academic placement as well, of course. Okay, so now that you have that, it's time to start writing the proposal. It was already mentioned a little bit in the previous talk. You do have to accept that the cutoff rates, and this means not just say the eligibility cutoff, but really the success rate, how many proposals are funded. They went from 20% down to 15%, and last year's they even dropped a little bit to almost 10%. And you see the scores that you require are actually on the order of 90 to 95% these days, at least in the chemistry panel. So you really have to focus on getting these very high scores. And in my personal opinion, that's also why I think this excellence criterion is very, very important. Because half of the weight of the scoring goes to this excellence criterion. Yeah. What does it mean in practice? It means you have to look at all these things that determine it. Yeah. For instance, what we got as feedback on our proposal was that, for instance, the prior competence of the researcher was much appreciated. He already knew a lot about, say, the topics that we were going to address, but also the supervisor has an excellent experience. Other things were that the project was very ambitious, but it was also achievable. We didn't oversell the project. It was quite interdisciplinary, going from chemistry to physics to engineering. We very well described the background, the prior art. And knowing the state of the art, we also clearly describe how we're going to advance beyond the state of the art. And of course, as was mentioned already in the previous talk as well, please pay attention to these open science practices, that you adhere to them. Then as a final thing, next to the science activities, the training activities are also very, very important. Yeah, you need to show that you're going to train the fellow in science, is going to develop new scientific skills, but also you're going to let him manage his own project, for instance, yeah, or her own project. The transfer of knowledge has to go two ways. You as a fellow, you need to bring something to your host that they didn't do before. On the other hand, your host has to be able to give you new skills, new, say, experience. Yeah. And like I said already a few times, in our particular case, this non-academic placement was really appreciated. yeah, because that gives you training beyond the academic environment. Okay, how do you start writing that then in practice? Well, the first thing is just, okay, this is not something you can change, and this is the existing situation. So make sure you highlight all these important elements and just be confident. Don't be afraid to showcase some of the, strong points of you as a researcher or the host as a supervisor. Then the second thing is that I asked my potential fellow to do is like, define now your research question. Yeah. Before you start writing your project, really think very carefully, what are my research objectives that I want to reach? Yeah. In this case, there were 3. You want to make nanocrystals, you want to investigate their properties, and you want to make this display pixel in the end. Yeah. So show here how you advance beyond the state of the art and how you have this interdisciplinarity, if possible, yeah, going from chemistry all the way to engineering, in our case, for instance. Another thing that I also advise the fellow to do is, once you have your objectives, make your timeline and make this so-called Gantt chart, because you only have 2 years. You only have 2 years to execute this project, and that means that within those 2 years, all the ideas, all the tasks that you have in mind need to be executable. Yeah, and as you can see here, for instance, the timeline shows that we are here in a manageable project. Yeah, so like I said, be ambitious, but also make sure that the project can actually be achieved. As you can see here also, then start thinking about the different milestones. What are the very important steps in your project? What important decisions have to be made where, the project can go either way? Yeah, that means that with those milestones, it's also good to have some deliverables associated with them. Yeah, how are you going to demonstrate that you achieved that milestone? And then once you have that, laid out, I always recommend to just start writing your project from A to Z. So the template is there. You already heard before that you have this clear template provided to fill in. Start from the introduction and go all the way from A to Z. Yeah. It's also not a problem if you are beyond the page limit during the draft, yeah, because you write a little bit too much in the beginning, and then you start cutting sentences, cutting sections, cleaning it up until you reach that 10-page limit, yeah. But the page limit is very important. It's a hard limit, and don't overflow that in the end, yeah. Okay, and like I said, all these different elements that you see here, your skills, the transfer of knowledge, project management, and so on, you will see that they come throughout those different sections and include them where they are appropriate. Of course, 50% went to excellence. There's another 50% which goes to impact and implementation. Of course, don't forget, still 50% goes to those 2 criteria. 30% on impact, 20% on implementation. Implementation is, for instance, how clear is this timeline? What are the milestones and deliverables associated with that, and so on and so forth. One other thing that goes into this section is the risk assessment of your proposal. And I do think this is very important. I do think it is very important because it allows you to show that you are aware of all the risks involved. Yeah, what are potential risks? Maybe you can make some material that doesn't satisfy all the criteria that you wanted to satisfy. How are you going to deal with that risk? Yeah, so how are you going to mitigate that? Make an actual plan. If the risk occurs, what are you going to do as an alternative? Yeah, just don't say it doesn't occur because you are experienced. No, really make a plan in case the risk occurs. Yeah, and that includes also training aspects. Yeah, it might be, for instance, that the secondment cannot be executed. Do you have a mitigation? That's all, very important to take into account. Once you have that, I think, the proposal itself is pretty much complete, but there's also the portal data. I wanted to mention this because this is sometimes a little bit overlooked, especially when you're, very much focused on drafting the proposal. Have a look at the portal data quite early on, okay? Make sure those sections are filled in properly. And again, as was already mentioned, these descriptors that allow the REA to identify the reviewers are very important, because they will determine the potential reviewers that you have, and say the more knowledgeable the reviewers are about the topic of your proposal, so the better those descriptors are describing the actual contents of your proposal, the better chances you have that you will receive, of course, an adequate, fair review. So that also means that you need to include some administrative information. On the portal, there needs to be administrative data from the applicant. That's what you need to do. But there's also some information that you need to ask from the host. Yeah, and make sure that you get this information in time. So the host will assist you in providing that information on the portal, but that will require some communication, some emailing back and forth. So take your time to get that information. And the same goes for the associated partner and the non-academic partner. They will have to provide some information. And especially if they are not, say, used to, say, EU proposal just yet, make sure that you do this on time. Start early on, because they need to get all the information on the portal, and they need to provide you with everything by the deadline of the submission. So if everything went well and your proposal is well evaluated and funded, you eventually go to the grant agreement stage. And I would say this is mostly something that you have to discuss with the project office. Yeah. So the project office will, in our case, handle most of the grant agreements, because in the grant agreement, the funding is fixed. So there's nothing to say, change, negotiate, or anything there. And also the topic, the grant itself, will describe the proposals that basically goes as a copy-paste into the grant agreement. Another thing that's interesting to know is that the funding goes entirely to the host. So this is good to discuss with your non-academic placement, is that the funding will end up at the host, and you can use as a fellow that funding to also, say, cover the expenses that you have at the non-academic host. Yeah, it does mean that it would be very good to also think about a joint research agreement with your partner. Yeah. So there was a work plan, you discussed it during the proposal stage. Copy this in your agreement with your industrial partner. Make sure you have a clear financial agreement. Yeah? If you have consumable expenses, other expenses that you will have during your stay at that non-academic partner, who's supposed to pay for what? Make sure that you have an agreement on that. Don't forget that this partner is non-academic, so they might have intellectual property. There might be some, say, discussion on, say, what happens to the results that you obtain during your non-academic stay. So make sure that's all, say, clearly discussed beforehand, including all kinds of confidentiality rules. Yeah. So that means that it would be good to well in advance of your start, I call this a secondment or replacement, and that you have this drafted and signed by all partners involved. Yeah. And if that is done, I would say you're all set to begin your project. So I would like to conclude this presentation with just summarizing the few main elements that I talked about today. So first of all, make sure as a potential fellow, find a good host. In that host, find a good supervisor, see where you can find a match, that you can bring some new skills to that host, but also that you can learn new things from that host. In the context of your potential future career, start thinking, is a non-academic placement something that is of added value for you, for your career? Yeah, and then talk to the host, which kind of non-academic partner would be suitable, which one could fit into your project. Yeah. Once you have that, just draft your proposal, and make sure, I want to emphasize this one more time, that you focus on the science, yes, but the training is at least as important as the science that you will actually do. So don't forget to emphasize all these training aspects as well. So with that, I would like to conclude my presentation,